Hello, everyone. We are going to start Unit 2 today. There are 4 sections of notes in Unit 2. We are going to do Unit 2, Section 1 right now in this recorded lecture. So Section 2 is called the properties of matter. All right, so when you're looking at matter, the properties can be broken down into either extensive properties or intensive properties. If they are called extensive, they are the ones that are dependent on the amount of the substance that you have. Such as mass, volume, weight. Okay, we've done mass, volume. You know that you know, those numbers can switch around depending on how much you have, how much spread out. So those are extensive properties. Depends on the amount that you have. Intensive properties are not dependent on the amount of matter that you have. It doesn't matter if you have a little microscopic speck of it versus, 1,000 grams of it. These properties will remain the same no matter what. So boiling point, melting point, its density, the phase of matter it's in, like liquid, gas, solid, that's not going to be any different. Depending on how much you have at all. That does not matter at all how much you have. And then of course color. Okay, these are just some examples of intensive properties. But again, intensive properties does not matter how much you have. They're always going to be the same. Extensive properties change based on the amount that you do have. Okay. All right, so I'm going to start throwing in these little tricks for understanding just to make sure that you are understanding what we're going over. So here's a table. It says it's giving you some properties of lauric acid. All right, so you have volume, mass, boiling point, and the number of moles. Now, we don't know what moles are yet, but that's okay. You can figure it out just for what you need to know for this. So which of these is an intensive property of the sample of lauric acid? So remember, we said intensive properties don't have anything to do with the amount of matter you have. So volume, we said that matters depending on how much you have. We said mass, that depends on, how much you have. Number of moles, so even if you don't know what moles are, the number of moles has to do with how much you have. So the boiling point is the correct answer for this one, in that boiling point is doesn't matter how much you have. It's always going to be the same. All right, specific matter can be described as a substance that always has a definite composition, it's always the same, and it has unique properties. So we can describe matter as consisting of elements, and they are chemically bound together called compounds. And compounds are going to be written out in a particular formula. Now, if you look under the example, you'll see I have table salt and I have sucrose. And they are written in the element symbols. For example, table salt, the Na, that means sodium, the Cl means chlorine. Put them together, it's sodium chloride. Now, if you notice, sucrose looks a little different because it's got numbers in the subscript, C12, H22, O12. Now, the subscripts are going to tell you how many atoms are present in that compound. If there is no number in the subscript, that is telling you there is only one atom of that particular element in the compound. So sodium and chlorine in the table salt, neither one of them have numbers in their subscripts. That's telling you that for table salt and one molecule or one compound, one molecule of that compound, there's only one atom of sodium and one atom of chlorine. On the other hand, if you look at sucrose, for every molecule of sucrose, there are 12 carbons, 22 hydrogens, and 12 oxygens. Okay. All right, you can also classify matter as a pure substance versus molecules. Now, pure substances mean that they are pure, which means they are only made out of one element or one compound. And again, they have unique chemical or physical properties. We'll talk about chemical and physical properties in a little while. Now, molecules, on the other hand, are compounds, but they don't have to be different elements. Remember, compounds pretty much have to be made up of more than one type of element, but a molecule does not. Okay, not necessarily. So it can be even expressed as just, one atom. So if you look, there's some examples there. You have a monoatomic element, you have a diatomic element, and then you have some common molecules down at the bottom. Mono means one. So this means it's made out of only one element. I've given you an example. It's just helium. Okay, you can see the symbol there for helium, just one helium. That would be monoatomic, one atom of an element. That's basically what it translates to. Di meaning two. This means two atoms of an element. Diatomic elements translates to two atoms for an element, or of an element. So I'll give you several examples. Bromine, and you'll see it's Br, that's the symbol for bromine on the periodic table. You'll see in the subscript a 2. Iodine, symbol I, subscript 2. That means there's 2 iodine atoms. Nitrogen, symbol N. You see the subscript 2. That means there's 2 nitrogens. So basically, this is telling you there are 2 atoms of that element in that particular molecule. And then there's common molecules such as carbon dioxide and water. And as we stated on this slide back here, they have a particular formula. Carbon dioxide, CO2, so there's no subscript for carbon or the C, so that means there's only one carbon atom, but you see the subscript of 2 for oxygen. So for every one carbon atom, there are 2 oxygen atoms bound to it. All right, so you can mix matter up a little bit. And when you define mixtures, that's just meaning the combination of 2 or more pure substances. And mixtures come in 2 main forms. You can have a heterogeneous mixture, if you remember from biology, when we did genetics, hetero versus homo. Prefix hetero means different, the prefix homo means the same. So heterogeneous mixtures, those are the ones that have elements and compounds that make it up, and they're not evenly distributed around the element of the compound, or the mixture, I'm sorry. So they're not evenly distributed in the mixture. There can be areas of higher concentration versus areas of lower concentration. For example, if you go dig in the dirt, okay, it's not going to be perfect. It's not going to be uniform. You might find some pieces of leaves. You might find some sand. You might find some clay. You might find some rock. So, there's a mixture of stuff, but it's not going to be all uniform. You're not going to have equal amounts of sand, equal amounts of rocks, equal amounts of leaves. Maybe chocolate chip cookies are a better example. You make chocolate cookies, and maybe you'll have more chocolate chips on one side of the cookie than you do on the other. Think about a pizza. You spread the cheese over it, but sometimes you have more cheese on one side. Sometimes you have more pepperoni. When they sprinkle the other toppings, they're not, it's not perfect. So, they're not spread evenly. Okay, they're not evenly distributed around it. All right, now homogeneous, again, homo means the same. So this means these mixtures do have a uniform concentration. There's an equal distribution of all the particles. This, for example, Kool-Aid, okay, you mix up Kool-Aid and water, it dissolves. There's pretty much a nice even distribution. Air, okay, is basically equally, just talking about in general air. I'm not talking about going somewhere that you might be in the bridge tunnel and there's like tons of carbon dioxide. I'm not talking about that. I'm just talking about like air, like right here. It's nice. 78% nitrogen, 21% oxygen, air. So evenly distributed in a homogeneous. And you can see the pictures over here, hetero. You can see there's a lot more of these purple molecules than there are the little teal color ones. And that's hetero, so not evenly distributed. And then you got homo, which means they are evenly distributed in the mixture. Okay, so let's look at this picture. Okay. What describes this image? So make note that you have the 2 larger white circles and they look like they're bound together. And then you have the 2 smaller black circles and they're pretty much bound together. So based on our definition, we have a mix of things in here. But is it a mixture of 2 atoms? Is it a mixture of 2 elements? Is it a pure substance or is it a mixture of 2 compounds? What do you think? In this case, we're looking at a mixture of two elements. Okay. If these were single, each one of these little circles represents an atom. All right. And you have the atoms bound together. Okay. Now they're the same element. Okay. They're not single atoms, so we're not going to include this. But we know we have two types. You have the little black circles versus the white circles. So we're going to eliminate pure substance right there because you got two types of substances, so it can't be pure. All right. So in this case, and then compounds we said have to be made of two or more different types of atoms. So if we're looking at each one of these individually, these are made out of the same thing. This one's the same as this one. Now, if we had a white circle and a black circle that were bound together, then yeah, that would be a compound because they're two different atoms or two different types of elements bound together. But all the white ones are bound, to each other, and all the black ones are bound to their particular elements together. So this is a mixture of two elements. All right, describing the properties of matter. Physical properties versus chemical properties. If it's a physical property, it means you can observe it without changing the actual chemical composition of the matter that you're working with. So you're not changing it at all. Physical change, like when you change the phases, you go from solid to liquid. If you're working with water, solid water is water. You change it to liquid water, it's still water. If you turn it into a gas, it's still water. Okay, it doesn't change the fact that it's not going to change it into something else. Physical properties, you can cut them into smaller pieces. Let's say you have a chocolate bar and you're trying to share it. You can break it into smaller pieces and everybody gets a piece of chocolate. Well, everybody's piece of chocolate is the same. It's still chocolate. Just because you broke it into smaller pieces doesn't change it into something else. On the other hand, though, chemical properties, those are going to change the atoms, rearrange them chemically, and they're going to form a brand new chemical. Okay, brand new chemical. Okay, so let's get to some examples. That would be best, and I can show you. Well, think about when you light something on fire. Okay, burning something. What it turns out that would be, a chemical property because you're going from, let's say, a piece of wood to now you've got a smoldering pile of ashes, and it's not wood anymore. Okay, so that would be a chemical property. When you add, you're making that volcano in middle school for science, and you add the baking soda and then pour vinegar on it. All right, that's a chemical reaction going on there. You're changing that baking soda by adding the vinegar, so that's a chemical property. And all that fizzing and bubbling, that's indicating that you've had a chemical change. All right, so let's look for some, let's see if we understand. The first question says, when examining the physical properties of an unknown substance, which of the following characteristics is unsafe to observe? Now, we covered this in our safety unit. We said you should never, ever, ever do this in especially chemistry class. So, you're looking at physical properties. A lot of times you use your senses to do that. Which sense should you probably not do while you're in a science lab? Unless you're told by the teacher it is okay, which is probably not going to be, but maybe one time ever. Your answer for that should be taste. We're not tasting anything. Okay, not that that's not a physical property. It is, but you're just not supposed to do it. Okay. Second one says, in order to determine the identity of a substance, the student listed the following properties. Which of the following is a chemical property? All right, which one's a chemical property? Remember we said chemical properties change the chemical composition. So A is oxidizes in the air, B is conducts an electrical current, C is the attraction to a magnet, D, it dissolves in water. So which one out of those four do you think is going to change the compound chemically? Or the could be an element too, but which one's going to change it? Hopefully you answered A, oxidizing in the air. Conducting an electric current, think about a wire. Okay, you got copper wires, you plug the stuff in, When you plug it in and the electricity is going through it, it doesn't change that wire. Okay, it stays the same. So its ability to conduct electricity would be a physical property. Attraction to a magnet, throw some magnets on the refrigerator. Okay, when they get stuck to the refrigerator, nothing physically or nothing chemically changes about them. That's a physical property. They're either magnetic or they're not. And then the dissolving in water, that would be if you think about when you like salt water and stuff, you can still get that salt out of the water. Okay, there's a way to do that. So it's not a chemical that's going to change. It's still salt and there's still water, and you can physically separate. Okay, and there'll still be salt and water. So oxidizing in the air. All right, and the last question, which of the following includes an example of a chemical property of an element? Is it aluminum is a solid at room temperature and is a poor thermal insulator? B, sulfur is not shiny and is not malleable. Okay, that has to do with metals and being able to, bend them and shape them however you want. Sodium is a solid at room temperature and reacts with other elements. And then the last one, which I can't read, the buttons are on the way, says silicon is shiny and has a poor conductor of electricity, or is a poor conductor of electricity. All right, so really one screams out at you with the word, hopefully you saw this, reacts. Letter C. Sodium is a solid at room temperature, and the part where it says it reacts with other elements, that whole reacting thing is a chemical property. All right, so we looked at physical and chemical properties. Changes can occur to an element or a compound or a molecule that can be either physical or chemical. Physical changes include the change in the location or the arrangement of the molecules, but you're going to end up with the same type of matter that you started with. There's no change in the type of matter. So, same thing as we talked about before. Physical changes can include things like your states. Like, did it go from a solid to a liquid or a liquid to a gas? It's still that particular, whatever you started with, but it's down a different phase. But if you know, things can go back and forth between phases and it doesn't change what it is. Chemical changes, however, this is going to rearrange the atoms and a chemical reaction occurs. So what you start with is not the same thing that you end up with. Okay, so look at our picture. You got the wood. Okay, you're chopping the wood. But even though you got smaller pieces of wood, those smaller pieces are still the same wood that you started with. They're just smaller pieces. You haven't changed anything about them chemically. On the other hand, when you set that wood on fire, and like I said before, you end up with the ashes, that's a chemical change because it's no longer wood. Okay. All right, so you can look for chemical changes of matter. Basically, chemical changes result in the substance being consumed to produce a new substance. All right, so some of the signs to look for to see if you have a chemical change is the formation of a gas or the formation of a solid precipitate. That means like if you have a solution and you start seeing like chunks of something form in it, those chunks are the precipitate. A change in temperature, okay? A change in color. We said color was a physical property, but if it changes color, that's a chemical change. Producing light, that means it's giving off energy, okay? So that's a chemical change. All right, so this is the end of this first section of notes for Unit 2. If you have any questions, please email me.